So here we have to find the value of this definite integral, right? So we have to manipulate the expression somehow so as to get it in good form. And we can see that, yeah, this is integral from 1 to 2 t to the power 4 plus 1. And the denominator is in the form a cube plus b cube. This is t square cube plus 1 cube. So it can be factorized and it can be written t square cube plus 1. That is the same as integral of t to the power 4 plus 1 upon this is a cube plus b cube. So this is factorized by the a cube plus b cube formula. This will be like this, and then t to the power 4 plus 1 minus t square, right? Like this. So now what I'll do to make it a bit simpler, I'll add and subtract a t square from the numerator. So that is the same as t to the power 4 plus 1 minus t square plus t square upon t square plus 1 times t to the power 4 plus 1 minus t square. Right, so when you split it, this will be like 1 upon t square plus 1 plus t square upon the whole denominator, right? And the whole denominator I'll again write in this form only because that will help me, right? So this is the same thing. T square upon the denominator is t to the power 6 plus 1 only, right? So I have broken up the integral in this form here, okay? This thing dot dt, right? Now the first part is very standard form, that is tan inverse t straight away, right? The first part, the integral is tan inverse t straight away from 1 to 2 plus then the rest of the thing I have to find yet 1 to 2 t square upon this t to the power 6. Now I will write as t cube whole square plus 1 dt. So this will help me. How? If t cube, I say, let's say p, right? So that means dp by dt is going to be dp by dt is 3t square. This will help me getting rid of that t square in the numerator. Okay. So t cube, I'll say, is equal to p, dp by dt is 3t square, right? So this thing here, only I'm writing this integral. This part is done, right? This part is done. This is simply tan inverse 2 minus tan inverse 1 after putting the limit, right? Tan inverse 2 minus tan inverse 1, okay? So this part here, the remaining part, after transforming to a new variable p here, I can write this is equal to t square upon p square plus 1 because t cube is p now I have taken. For dt, I can write this is dp upon 3t square, right? dp upon 3t square. Okay, this t square cancels this one. And this is again in a very good form. This is 1 by 3 integral dp upon 1 plus p square. Again, this is in the standard form. The integral for this is tan inverse p now, right? So this is nothing but 1 by 3 times tan inverse p. But since we have changed the variables, right? T cube is p. So t was from 1 to 2. So p is going to be from 1 to 8 now, right? Using this term, if t is 1, p is 1. If t is 2, p is 8. So here the limit is 1 to 8, right? So this part here will ultimately become tan inverse 8 minus tan inverse 1 upon 3, summing up the whole thing. Now the final answer, if I try to find out, I will get this thing here plus this thing here, right? I'll put the values even. Tan inverse 1 I know is pi by 4. Tan inverse 2, I don't know the value. Let's keep it like that. Tan inverse 2 minus pi by 4. For tan inverse 1, I wrote pi by 4. And then plus, this is tan inverse 8 plus tan inverse 8 by 3 minus again tan inverse 1 here is pi by 4. So this is minus pi by 12, right? So ultimately you'll get the answer to be, this is going to be tan inverse 2 plus tan inverse 8 by 3 minus, that is going to be pi by 3, right? Minus pi by 3. So this is my final answer. Tan inverse 2 plus tan inverse 8 by 3 minus pi by 3. Option number 3 here becomes the correct answer. Okay, this here becomes the correct answer, option number 3. Okay, thank you.